My name is Hazel Barton. I'm a professor at Northern Kentucky University, and I study microorganisms in caves and try and understand how microorganisms adapt to starved cave environments. I've been caving for 20 years now, so I started caving basically on a weekly basis at the age of 16, and just for fun, for exploration, survey, mapping, trying to find out where caves go, trying to find new caves. You know, people used to think that caves were completely lifeless, nothing was in there. And now we have, you know, organisms that can trap carbon dioxide from the atmosphere. We have organisms that produce antibiotics. We have organisms that are good at bioremediation. They can remove plastics out of the environment, so they might be able to, you know, clean up environmental spills. None of this would have happened if we hadn't, you know, been able to take those two things together and start looking. To be in a cave, obviously the first thing is there's no light. So you have to deal with that. So you take 3 sources of light, because if one fails, then you have some backups. And light goes out, you're pretty much stuck. And you need to take helmets, and you need to have some training on how to move safely for a cave. It's easy to get lost. They can be very confusing passages. On the way in, they look very different from the way out. But, you know, there's pits and climbs and loose boulders. They certainly are a geologic environment. They weren't made for us to travel in. The other thing we're doing, and I think something that's a lot more practical, is trying to understand how microorganisms contaminate the surfaces of spacecraft. So when you build a spacecraft and you send it to Mars, you got to make sure there's nothing on it, because when it lands, they could fall off, and then you could start populating Mars with organisms from Earth. And this is a real problem, and the interesting thing is that the organisms you find in spacecraft assembly facilities, where they actually build them, are the same as the ones we find in caves. And the reason for that is because of starvation, the same ways of getting energy and nutrients that these guys have figured out in caves allows them to survive in these clean room environments. So by understanding caves, we can kind of give some input to NASA on how to limit the number of organisms in these environments. The problem with Mars is the surface of the planet is a really toxic environment. It's very oxidizing, which means if you're any kind of biologic material, you're going to get destroyed basically. It's like pouring hydrogen peroxide on a wound up there. So if there's any microbes, they're going to be destroyed. And there's a lot of UV radiation that hits the surface. There's no water. So if anything's going to be alive, it's going to have to be underground. We have some evidence that there are caves on Mars. So, you know, the possibility of there being subsurface environments is, you know, fairly high. So if we can understand how organisms live without nutrients and energy from the surface like they'd have to on Mars, then we can try and understand what kind of life would we find, what kind of footprint would it leave behind, so we would know that it was there even if it wasn't alive anymore. Research is a lot like a metaphor for cave exploration. You know, when in a cave, you don't know where it goes, it's dark, you kind of have to figure out your way through, find the route through the cave, and research is just like that. You know, you don't know where you're going, you kind of have an idea and you just have to keep testing, and you know, it's very exciting and it pulls you in new and interesting directions. And I think doing the research for the research sake is certainly much more of a motivator than, you know, maybe being on TV or something.